До нас приєднався офлайн, я ще раз підкреслю, Чарльз Коккел. Давайте поаплодуємо. Містер Чарльз. Професор астробіології Единбурзького університету Великої Британії, співдиректор Центру астробіології Великобританії, який він створив. Чарльз вивчає життя в екстремальних середовищах, придатності для проживання підземних середовищ і дослідження космосу. Чарльз, we are very happy you are here with us. Welcome. Make some noise. Дякую.
Дякую.
Please.
Добрий вечір, друзі. Я дуже щасливий бути тут в Києві. Друзі, я хочу говорити українську мову, але я почав вивчати українську мову 9 місяців тому. Моя українська мова дуже погано. Якщо я говорю українською, ми будемо тут багато місяців. So I must speak англійською. Okay,
так, а давайте гучніше поаплодуємо. Чарльз, thank you. Very nice, Ukraine. Thank you.
Thank you. So I'm Charles Cockell. Я працюю в Единбургському університеті. Я професор астробіології. And today I want to talk about life in space, how we search for life in space, and how it might help us on Earth. And in my laboratory, we study life in extreme environments. In fact, the last talk was fantastic. I worked for 5 years at the British Antarctic Survey, so I'm very familiar with Vernadsky Station. It's wonderful to hear about the research going on there. So in my laboratory, we study life in polar environments, in deep underground, in volcanic environments, to try and understand how we might look for life in space. So my talk, I'm going to start off with just to tell you a little bit about the amazing new discoveries and possibilities in the search for life beyond Earth and why we want to do this. Then I'm going to explain how the search for life in space can help us on Earth. Why would we even be interested in looking for life in space? How is it useful for us? Then I'm going to say a little bit about how Ukraine contributes to this area of research and how it might be expanded. I should say that the University of Edinburgh has a partnership agreement with Taras Shevchenko University, so we see lots of possibilities in the coming years. And lastly, I'm going to talk about why do we do this at all? Why are we interested in the search for life on other planets? And why would anyone ask this question, particularly in times of crisis, in times of war? This seems like a very trivial and unimportant question. So I want to touch on why we should continue to ask the question, is there life elsewhere in the beyond Earth? This to me is one of the most interesting scientific questions. Великі питання, можливо, найбільші питання на науці, я думаю. I think this is a very interesting question. And the reason why it's interesting is because if we look out into the universe, we see galaxies and stars many light years away, and yet as far as we know, the Earth is the only planet so far in the universe to have life. So biological sciences is a one-planet science. Biological sciences currently exist only on one planet. And that is an amazing thing when you think that physics and chemistry can be used to explain the nature of the entire universe, and yet biology is just here. Or is it? And that's the question we want to answer. Now, people have been thinking about this for a long time. The ancient Greeks wondered about whether there were other planets harboring life. Of course, in ancient Greece, their views of the universe were very different from ours. They did not understand that little white spots in the sky are stars. They did not really understand about planets. So they didn't really ask the same sorts of questions as we do. But amazingly, 4 centuries ago, Giordano Bruno, who was a sort of philosopher, early type of thinker in this area, he wrote this: in space there are countless constellations, stars and planets. We see only the suns because they give light. The planets remain invisible, for they are small and dark. There are also numberless Earths circling around their suns. Now, this is an amazing statement because it's 4 centuries old, and yet here is Giordano Bruno speculating on exoplanets, planets orbiting distant stars. Exoplanets were only properly discovered in the early 1990s, and yet he was thinking about exoplanets 400 years ago. And not only that, he was also speculating that many of these exoplanets might be the size of Earth and might be capable of supporting life. So I just wanted to show you that this idea of extraterrestrial life, it's not new, it's not a recent idea. People have been thinking about this for centuries, but it is only during the last 2 or 3 decades, and only in the next 2 or 3 decades to come, that we will finally get an answer to the questions of whether there is life elsewhere in the universe. And that is what makes this period of time so incredibly exciting. So this is not actually a picture of the Milky Way galaxy, because we have no such picture. But if you went a long way away and you looked back at our galaxy, this would be where you are, about 2/3 of the way outside the center of the Milky Way galaxy. Our galaxy has about 200 billion stars. And if you look into deep space, this is an image taken by the Hubble Space Telescope. Every single one of these little spots of light is a galaxy containing tens or hundreds of billions of stars. So you can see why, purely from a statistical point of view, it's a reasonable question to ask, is there life elsewhere in the universe? Is it really possible that there could be life on Earth, but nowhere else in this vast universe of possibilities? And that is the question that we wish to answer, and which we will develop the technology to answer in the coming decades. If you watch movies and the media, you will know that people are fascinated by intelligent aliens. They often look like us, these. And the reason for this is, of course, if we were to find intelligent extraterrestrials, this would be tremendously exciting because we would have other creatures with which we could communicate. But in fact, the likelihood of this being the case is very small, and the most likely things that we will find elsewhere in space are probably microorganisms, the microorganisms that we heard about in Venadski Station a moment ago. This is Escherichia coli, which is a bacterium that lives inside your gut, and it's about 1,000th of a millimeter long. And on the right-hand side is a picture of a hot spring in Yellowstone National Park in the United States, which also is full of microorganisms. Life emerged on the Earth about 4 billion years ago, and animal life only emerged in the last sort of 500 million years, and intelligent life only in the last, well, tens, hundreds of thousands of years. So if you look at the history of our planet, most of the history of our world was dominated by microorganisms, bacteria, archaea, these microscopic organisms, not intelligent life. So this would be very exciting, but it's not necessarily very likely. In fact, the most likely life we will find on other planets is probably microorganisms. And that may not be very exciting to many of you here, but for me as a microbiologist and one of the last speakers in the last talk, this would be very, very exciting to find microbes, because it would still be life. It would still be life elsewhere in the universe. So one of the first places where people thought there could be life is the planet Mars. And this, at the moment, is a focus of efforts to try and look for evidence of past life. We know that About 4 billion years ago, the planet had much more liquid water than it does today. This is an artist's impression of what Mars might have looked like about 4 billion years ago. And it may have had an ocean. It certainly had a lot more liquid water. And the problem with Mars is because it's smaller than the Earth, a lot of that water evaporated, it froze, it was stripped away from the atmosphere in its early history, and all that water disappeared and got frozen into the planet. And today, Mars is a desert world. It has very little water. In fact, it's a little bit like some of the dry deserts on Earth. However, if we go to Mars and we drive around the surface, this is a picture of the Curiosity rover, what we will find are these sediments that are made up of layers of mud that you can see on the right-hand side. These are layers of material that fell out of a lake that would have existed on the early history of Mars. And these sorts of sedimentary layers tell us that this water existed for many millions of years. Now, if you went to an environment on Earth where there is ancient sediments laid down in a lake, in a volcanic environment, like, for example, Iceland, and you found material like this, you would probably have a very good chance of discovering evidence of ancient life in that rock. So this is very tantalizing because after centuries of speculation, finally, we have images of rocks formed in a lake where there was lots of water for millions of years. And the question is there any life, or was there any life in those rocks? And if you're an astrobiologist like me, you look at these and they're just very exciting rocks because all you have to do is get a sample of this rock and bring it back to Earth, and then we could look for evidence of life. And this is what the Mars Sample Return mission is designed to do, is to collect some of these samples and bring them back to Earth. So you can see why this is exciting, because we've thought about the possibility of life on Mars for many centuries. Now we have an environment that had all the conditions that were probably supportive of life, and in the next few decades we could go and collect samples and we could finally answer our question, was there life on Mars? And this is a very sort of privileged time in history, in scientific history, to be around, to finally be able to sample these sorts of rocks. Now, if I was standing up on this stage, say 40 years ago, that would have been the end of the talk, because there would be nowhere else to think about looking for life. However, in the last 2, 3, 4 decades, we found other places in the solar system that we think might also support life. So if you go out to the outer solar system, to these planets like Jupiter and Saturn, very cold, these are places where people thought there could never be life. If I had stood here 40 years ago and said, I'm going to look for life around Saturn, you would have thought that I was crazy, completely mad. And yet, we now know of planetary bodies orbiting these planets that contain liquid water. And this is Enceladus, which is a moon of Saturn. It's about 500 kilometers in diameter. And this is an image taken by the Cassini spacecraft of plumes of water coming out from inside this moon. And on the left-hand side, an artist's impression of what might be inside the moon. And there is now very good evidence, geophysical evidence, and other evidence besides, that tells us that there is an ocean inside this icy moon. How do you get an ocean so far away from the sun where there's so little energy? Well, if you imagine taking a spoon or a fork and bending it, you will know that it gets hot. And that is because of the friction in the molecules that heats up the fork and it begins to warm up. If you take a moon like this and you move it around as it orbits Saturn, as it interacts with other moons, those tidal forces cause the rocks to move around. And like our bending fork, as we move those rocks around, we heat them up. And that heat melts the ice and creates an ocean inside the moon. And this is how we have water gushing out from an ocean beneath the surface of this icy moon. And the Cassini spacecraft was able to fly through these plumes and was able to look and see what they were made of. And what they were made of was water and lots of complex organic carbon compounds from which life could be made. So here's another exciting thing. Is there life in Enceladus? Well, we don't know. But within the next 10, 20 years, what we could do is build a spacecraft, and we could fly through those plumes, collect a sample, study it in a laboratory, and then we would have an answer to, is there life in the oceans of Enceladus? And that, again, is incredibly exciting. Imagine going to Giordano Bruno, who was speculating about alien life, and telling him that we found an ocean on another world, and we can get samples of that ocean and look for life within it. He would have been completely astonished. And that's what we're going to be able to do. And not just in Enceladus, there are other moons like Europa, which is a moon of Jupiter. Even Pluto may have an ocean just beneath its surface. That's one possibility. So things have come on a long way, and what we now know is that there are many places in the solar system where there could be life. I am a bit of a space geek, so this is a painting that I asked Richard Bisley, who is an astronomical artist, and I sent him an email. I said, I want you to paint me a team of astrobiologists on the surface of Enceladus who have just discovered something really exciting. And maybe there they are. And maybe this is the Ukrainian away team who have just gone from Vernadsky to Enceladus, and now they're going to look for microbes in the ocean of Enceladus. So this person here is taking a selfie or a picture of them. These are the plumes of Enceladus, and this is their little spaceship where they've landed. This is not going to happen in the next 10 years, but maybe in 200 years, we will have astronauts on Enceladus looking for life. One of the most exciting frontiers in the search for life is the possibility of looking for life outside our solar system, just like Giordano Bruno speculated those 400 years ago. And I mentioned that in our galaxy alone, there are about 200 billion stars. So what we want to do is to search for a second Earth around a distant star. When I say a second Earth, I don't mean an Earth that's exactly like, or another planet that's exactly like Earth. We will not find such a world. What I mean is a planet with oceans, possibly with continents, and possibly with conditions supportive of life. And what the holy grail, if you like, in astrobiology is to find such a planet elsewhere in the galaxy. And here again, we will look for these planets within the next 20 years. So we will start to get answers. We already know that there are strange worlds out there that are very, very different to our own planet. This is the Kepler Space Telescope that had an amazing career of looking for planets orbiting different stars by looking at the way in which they move in front of stars. And it found worlds that are very strange and different to Earth. These are not real images, but we do know now of planets orbiting multiple stars. If you were to go to some of these planets and stand on them, you would be woken up by 3 sunsets. Imagine waking up in the morning in Kiev and seeing 3 suns in the sky, a triple sunset or a triple sunrise. So these can be very different planets to our own world, and they may be very alien, but they may still support life. How will we look for life on these planets? Well, what you can do is you can look at the light from the star around which that planet orbits that comes out of the planet's atmosphere. So as starlight passes through a planet's atmosphere, the planetary atmosphere contains different gases, and those gases will absorb different wavelengths of light. They will rob the light, they will take light away as they absorb different wavelengths. And you can look at that light through your telescope, and you can work out what the composition of the atmosphere is. So if I was an alien many light years away, and I built a telescope, and I pointed it towards our solar system, I could tell something about the planets in our solar system. And if I pointed my telescope towards Venus, what I would see is a spectrum of light and then a big dip caused by carbon dioxide, because the carbon dioxide molecule is absorbing that light from the stellar radiation, and it's causing a dip in the spectrum. And I would know that Venus has carbon dioxide in its atmosphere, which we know to be true. If I took my telescope and pointed it towards Mars, I would also see carbon dioxide, and it would tell me that Mars has an atmosphere that contains carbon dioxide. Maybe not very interesting, but I would have some information. Now what would be interesting is if I turn my telescope towards this strange blue world, which we call Earth, and I look through my telescope, I would see something very interesting. I would see carbon dioxide, because our planet has carbon dioxide. Not very much, but enough. But what I would also see is absorption caused by water, and that would tell me that this planet has oceans and possibly an atmosphere. And I would also see ozone, which is a gas formed from oxygen in the atmosphere. Our atmosphere has about 20% oxygen. That oxygen reacts, or is reacted by ultraviolet light and forms ozone. There is only one way in which you can produce large quantities of oxygen in such a world, and that is by photosynthesis. There are some other ways of making oxygen, but you can rule those out, and you can tell that the oxygen on our world forming this ozone comes from life. So this is what we call a biological signature, a biosignature, and it would tell us, the aliens would know that there was life on planet Earth. And in the next 10 or 20 years, new telescopes, like the Habitable Explorer telescope is going to be built, the Habitable Worlds telescope rather, and it will look at the atmospheres of distant planets, and we will be able to look for signatures of life in the atmospheres of these planets, and we will be able to tell whether there is a second Earth out there in the galaxy. And maybe one day we will build even bigger telescopes that will look for land and continents on the surface of these worlds. So these are the exciting frontiers of looking for life. And just to summarize that part of my talk and to remind you, we have been thinking about alien life for hundreds of years, and yet in the next few decades, we will finally get some sort of answer. So you might ask, is any of this research useful? Why does someone like me think about these things? Well, the scientific question is interesting, is there life beyond Earth? But in the process of studying microbes in extreme environments and how they survive different extreme conditions, which is what we do in my laboratory, we also isolate and study microbes that could be useful in industrial processes. So this is an experiment that my laboratory launched to the International Space Station about 3 years ago, where we studied whether we could use microbes to extract elements from rocks. And BioRock was a biomining experiment. About 25% of the world's copper and gold is extracted from rocks using microorganisms. This is called biomining. And the reason why people do biomining, because it's a lot more environmentally friendly than using very unpleasant chemicals like cyanide, for example, to extract elements from rocks. So we're interested in finding microbes that will allow us to do mining. And in these experiments, we were able to use microbes on board the space station to show how we could use these organisms to plan future settlements beyond the Earth. These are our microbes going up into space. These are basically our holiday photos. It's very, very exciting when you spent 10 years planning a space experiment and you finally see it being launched into space. So those are our microbes up there, and those are our microbes in there. It's very, very exciting to see them taken on board and the experiment conducted. And we were able to show that microbes could extract elements from asteroids and therefore could be used in future space settlement plans to extract useful elements and support the development of human stations beyond the Earth. Similar stations to Vernadsky, but on Mars and the Moon, where people would need to get elements and food and to be able to produce useful products. Now, when we do that research, we learn fundamental things about science that can help us on Earth, because we want to be able to protect the environment on Earth. And this is what mining does to the environment. As you can appreciate, mining is not a very clean process, but if we can find microorganisms that have been mining rocks for 3.5 billion years to extract elements, then we can do these things a lot more efficiently, we can do it more cleanly, and we can do it in a way in which is compatible with the way in which microbes have been eating rocks for many billions of years. So this biomining work is work that we do in my lab. We work with companies, other universities, to look at the extremes of microbes to understand how they work and how we can apply them on Earth. So this idea of, is there life beyond Earth, makes us plan experiments to go into space to understand how life can survive in space. And in the process of doing that, we learn something about microbes that could be useful on Earth. So all of these things are connected, and space can help us on Earth, just as studying microbes on Earth can help us get into space. So I have collaborations. Some of my colleagues, I think, are in the audience, and we've been talking about astrobiology in Ukraine. There's all sorts of interesting things that we can do. Of course, first I should point out that Ukraine has a long heritage in space exploration and the development of aeronautical engineering, instrumentation, optoelectronics, computer science. These things go back many, many decades. But I'm particularly interested in the connections between astronomy and planetary sciences and biology, at what we might call astrobiology. So last year, I came here to Kiev, and we had a fantastic conference at the main astronomical observatory. Yaroslav Yatskev, who's here, and Natalia Kozyrovska at the Institute for Molecular Biology and Genetics, both institutes of the National Academy of Sciences of Ukraine. We had a conference on astrobiology to talk about what might be possible and how we could build further collaborations. One of the things that we could do is make better connections between planetary sciences and biology. And this week, I hope to talk to colleagues and friends at Taras Shevchenko University, National University here in Kiev, to see how we can make more scientific collaborations. We could also build on the expertise in instrumentation, in hardware development. I'm not an engineer or someone who builds instruments, but I work with colleagues who do, and there are all sorts of possibilities, I think, in developing astrobiological instrumentation. Of course, Ukraine could also connect across international scientific networks and organizations. Some Ukrainian colleagues are already members of the European Astrobiology Association, Network Association. So I think there's possibilities for more connections with institutions. Ukraine could plan its own missions and build its own spacecraft. That also would have been a crazy suggestion 40 years ago. But as you've probably noticed, there are many private companies now launching rockets into space. In fact, our own experiment to the space station just 2 years ago went by commercial launcher. It was the first scientific experiment in the United Kingdom to go into space through a commercial route rather than the European Space Agency. So there's no reason why Ukraine cannot build astrobiology and space missions and fly them through commercial routes. And I hope to have a discussion about that with Taras Shevchenko University, and maybe think about how we can do that. And then finally, of course, as all of you are aware, that we've seen today a fantastic talks. I have to say I've been completely amazed by what I've heard today. There are existing connections in Ukraine in health, environment, medicine, and so many other areas that are incredibly well developed. And just like in the UK, these areas tend to be disconnected with space sciences and astrobiology. And as we are trying to do in the UK, it would be really good in Ukraine if we could connect space sciences with this existing expertise in medicine and environment and health. And there's a heritage there and a capability that can be built upon. So finally, I just want to finish off my talk just by saying a couple of brief things about why do we think about life in the universe at all? Isn't this just a ridiculous question to be worrying about in a world of troubles? This is the Earth, little dot here, in a beautiful image of Saturn, taken from behind Saturn. And this is our little world on which we live, where everything that's ever happened on this planet, every act of history has occurred, as Carl Sagan once pointed out. A little dot. Why would we care about life in the universe? Well, I think there are two reasons. First of all, And it was mentioned earlier today by one of the speakers, I forget who it was. Science is a very important thing for the development of any society. And one of the reasons for that is that science is a questioning activity. Science does not really accept any fundamental truth. In fact, the job of scientists is to question what we think is true and to challenge people with new ideas about the way the universe works. So from a purely mental point of view, science is a very healthy mechanism in society for creating open deliberation and discussion in any fully democratic and open society. Science always has a good role to play in encouraging people to think, to question the status quo, to raise new questions about not just the universe, but the way society works. And so it's very important to encourage good science. And that science does not necessarily have to be applied. It can also be fundamental questions like, is there life elsewhere in the universe? That's all part of the contribution to society. And then finally, I think I would just make the point that asking questions like this is really fundamental to what our civilization is. You may have noticed that chimpanzees do not build radio telescopes. Okay? They do not ask questions about the fundamental nature of the universe. Elephants do not build rovers and send them to Mars to look for life. We are the only species on this planet that builds machines to try and understand how the universe began, why we're here, is there life elsewhere? These very big questions are really what emerged when we started to build a civilization, and they separate us from the rest of the biosphere, not necessarily always in a good way, but they do fundamentally separate us from all other animals on Earth. And regardless of the situation we find ourselves in, whether it be a global crisis or war or these sorts of situations, we should not allow people to take away from us the opportunity to ask these questions and to think about the universe, because it's part of our humanity. So when people say to me, why are you asking about life in the universe? We should be building hospitals and roads. And maybe you might be thinking, why is this person talking about life in the universe when we have full-scale invasion going on? I would say we should not allow people to take away our humanity and our ability to ask big questions. And in fact, it's when things get difficult is the very time that we should insist on asking, is there life elsewhere in the universe, some of the big scientific questions. Because in that way, we can hold on to what it is to be human and to ask some of these interesting and profound questions about the nature of the universe and our place in it. So thank you very much, Дякую, друзі. It's been excellent to be here and to be back in Kyiv. Thank you.
Thank you. Питання-відповіді. Ну що, клас. Багато запитань, тому, будь ласка, якщо можете англійською, будемо раді. Дякую.
Oh, yeah.
Thank you very much for your presentation. Thank you for coming here as well in this difficult time. So my question is, you talked about life on Mars, on Europa, on Saturn's moons, and you talked about collecting samples. What are the issues with transporting those samples for analyzing them, or are there any methods of analyzing them at the spot? Do you have any technologies of doing that? Thank you.
Yeah, this is Cikava Pitanya. The question is, how do we analyze samples from other planets? I think it's very difficult because the samples are often very small and we don't have many of them. So it's possible, for example, if you went to Mars and you collected samples and you brought them back to Earth and you looked for life, you may still not get an answer, or you could look at the samples and think, I'm not quite sure, I'd like another 10 samples. So this is one of the problems. This is why personally, I'm very, I favor sending human beings to other planets, because if you put a group of astronauts on the surface of Mars, just like you saw that research team in Vernadsky, they can do a lot of research very quickly and much more quickly than a rover. So I think that you should send humans to Mars and look at a large number of samples. The analytical capabilities are also an interesting problem because, of course, on Earth, you can have a laboratory the size of this room that's full of very sophisticated equipment, and you can get very good answers on what is in your sample. Whereas when you take that equipment and you shrink it down onto a small rover, the equipment is not so good, and it's not as good as finding answers. So here again is a problem that even the best rover with the best technology may still give you answers that are a little bit ambiguous, not very well defined. So I think you send, this is a personal view, I think you send a laboratory with lots of really good instrumentation and a crew of scientists to these places to look for life.
Thank you. Так, у нас ще є час на 2 запитання. Будь ласка. Ось поруч, і потім...
Yes, hello. Thank you for such inspiring lecture. It was pretty great. And I have a similar question, but about our reaction here on Earth. I think that it's probable that we will have some panic attack about, well, aliens from the space coming here on Earth.
Yes.
And yes, can we have some kind of precautions for make it safer to study the samples on Earth? And is it really some kind of dangers in this?
Yeah, this is also an excellent question. So, excuse me. The problem of samples, bringing them back to Earth, and maybe they are dangerous. So imagine that you had microbes on Mars, and you put them in a spacecraft, and Mars is very cold, and it's a very desert-like place. Imagine these samples crashed in Antarctica and were released, and they started to grow. What would happen? Well, we don't really know, to be honest. And I think most people's view of the question that you said is that we should send robots, at least to begin with, to find out if there is life there, and we should be very careful about bringing samples back. So the Mars sample return proposals in the United States to study Martian samples, they would involve building a laboratory with very, very strict containment, similar to the sorts of containment that you use to study dangerous viruses. Because even if there's nothing dangerous in there, you don't want to release something that turns out to be dangerous. No one wants to go to to lunch and have to explain to their colleagues that they destroyed the Earth's biosphere because they accidentally brought a sample back from Mars that contains some dangerous microbes. This is a very embarrassing thing to do. So what you want to do is study the samples quite well beforehand, and then you can release them into the wider community. So you can bring samples back to Earth, but it's probably a good idea to study them in a closed laboratory before you start sending them to laboratories all over the Earth. But it is something that people worry about, and they are correct to worry about. The other thing that people worry about is contaminating a biosphere somewhere else. This is called forward contamination. So if we were to take microbes from Earth, and this is a more likely scenario, and contaminate Mars, what would happen if we destroyed or damaged a Martian biosphere? So again, some people would say that we should send completely sterilized robots to Mars, we should look for life, and we should determine to some level of confidence whether there is life on Mars before we start sending more robots that are not sterile or human beings. I should say that we have already sent robots to Mars that are not sterile, so we have already contaminated Mars, but that doesn't necessarily mean that we can't improve in the future. This is a really interesting question. It's an interesting question because it intersects between science and ethics and morality and other areas that are quite difficult to examine from a scientific point of view, but they're very, very important questions.
Будь ласка, ще останнє фінальне запитання. Будь ласка.
Hi, thank you so much for this info. It's so interesting. I was wondering, let's imagine this day comes and we find some life on some other planet. What are the next steps? So what do we do next?
Yeah, okay. So what do we do next when we find life? Well, I suppose one question that we might ask ourselves is that life related to life on Earth? So we know, for example, that in the early history of the planets, asteroids and comets landed on Earth and Mars and threw rocks up into the solar system. It may surprise you to learn that about 1/2 ton of Mars lands on Earth each year. Most of it is in the oceans, most of it is in small rocks, but there is material being exchanged between the planets. And that means that in the early history of our solar system, when there was life on Earth, could it be that life was transferred to Mars? So if we had a sample of life from Mars, we could ask ourselves, is it related to life on Earth? Is it connected to life on Earth? Or was it a completely independent origin of life? Did it start completely independently? And that would be an interesting question because it might tell us whether the origin of life is an easy thing to happen or whether it's very rare, whether life in the universe, life at least in our solar system rather, is related, or whether in fact we had multiple origins of life. If it turned out to be a different biochemistry, this could be very exciting. Imagine what we could learn about biology with a completely different form of life. Maybe there may even be practical implications. We might learn how to make new types of genetic information. Could be useful for pharmaceuticals, could be useful for understanding even how we can improve health by learning new types of biochemistry from alien life. So we have no idea what we might discover 300 years ago or so when microorganisms were first discovered on Earth by Antony van Leeuwenhoek. It opened up the whole science of microbiology. And now, of course, we have medical microbiology, environmental microbiology, all sorts of areas that are important for disease, for health, for the environment. Who knows what sort of science would open up in front of us if we did actually find a sample of life on another planet. But let me make one final comment. Even if we found no life elsewhere in the solar system, that would also be very exciting. So sometimes people say to me, you're an astrobiologist. What happens if you find no life? Do you still have a job? And so I like to remind people that if we found no life elsewhere in the solar system or on any exoplanet, that would actually be incredibly exciting because it would tell us that Earth, as far as we can tell, is the only planet, at least in our observable sphere, that has life. And it would tell us that the origin of life was very rare, very unusual, very difficult to happen. And therefore, we would have to try and answer the question, why did life emerge on Earth, but we can't see it anywhere else? So a lack of life in the universe is just as exciting as finding life. It just opens up slightly different questions.
Thank you. Давайте ще раз поаплодуємо. Thank you. А давайте гучніше ще раз поаплодуємо. Через Cockell. Дякуємо вам.